This video series goes through the daily problems in this maths calendar that is published by the American Mathematical Society. You can either purchase it through their website or via Amazon. Today's question asks us to evaluate I minus 1 all to the power of 8. Here I is the square root of negative 1. The first method is simply to take I minus 1 and square it 3 times, because something to the power of 8 is the same as squaring it again, and squaring it a third time. I minus 1 squared is equal to I squared minus 2 I times 1 plus negative 1 squared, which is I squared minus 2i plus 1. I squared is negative 1, which cancels with the 1. We're left with negative 2i. Negative 2i squared is equal to negative 1 squared is just 1, 2 squared is 4, I squared is negative 1, gives us negative 4. Negative 4 squared is 16, giving us the answer of 16. For this particular problem, probably method 1 is the faster solution. In general, we can use method 2. A complex number is the sum of a real number plus an imaginary number. In our case, the real part is negative 1 and the complex part is I. So we think of the complex number I minus 1 as this point here in the complex plane, having a real coordinate of negative 1 and an imaginary coordinate of I. In polar coordinates, the same point can be specified by its magnitude, which is the distance from the origin, and by the angle it forms from the positive real axis. To find its magnitude, we use Pythagoras' theorem. This point is 1 unit across and 1 unit up. So by Pythagoras' theorem, its magnitude is the square root of 2. The angle, first we have 90 degrees to get from the real axis to the imaginary axis. And then this point here, being exactly 1 unit across and 1 unit up, would give us half of 90 degrees between here, or 45 degrees. Or in terms of radians, we have a distance of pi on 2 from here to here, and an extra pi on 4 from here to here, giving us a total angle of 3 pi on 4. Therefore, the point I minus 1 is the same as the square root of 2 e to the I 3 pi on 4. If you wish, you can verify this by using e to the I theta equals cos theta plus I sine theta. If you compute the cos of 3 pi on 4 and the sine of 3 pi on 4 and put those in here, you'll recover I minus 1. Once in polar form, so to speak, raising a number to the power is straightforward. The magnitude just gets raised to the same power. The square root of 2 we write as 2 to the power of a half. Raise it to the power of 8. A half times 8 is 4, so this will become 2 to the power of 4. The complex exponential part, when we raise it to a power, we just keep going around the circle that many times. So raising e to the I 3 pi on 4 just gives us e to the I 3 pi on 4 times 8. That gives us e to the I 6 pi. 6 pi is a multiple of 2 pi. Precisely, we go around the circle 3 times. We end up back where we started, meaning e to the I 6 pi is just 1. Therefore, the answer is 2 to the 4 times 1, or 16.